Hi, for those that don't know me, my name is Nico. I work with Guille, Paulo, and Noel in the Pharo VM team. And I've been working for a couple of months on extending Pharo using vector instructions. For those that don't know what vector instructions are, and were not here when Guille explained what vector instructions are yesterday, we can see it with an example. Let's say that we have an array, actually two arrays, and we want to add them element by element, right? And just store the result into a third array. One way to do it is like the scalar approach, which is just, okay, let's take both arrays. We first read the first position of each. We load them from memory to CPU. We add them together. We store the result somewhere else. Okay. The alternative is what we call the vectorial approach, actually what everyone calls the vectorial approach, which is let's take a chunk from each of the arrays. Let's just load them all together, and let's operate on the two chunks at the same time. So basically, for example, if we can fit 4 elements of the array into registers, we just load 4 things, then we operate on them and we store the whole chunk. And that way we do the same job, but way faster, because we can do each operation in a single CPU tick. So why do we care about this? Well, because of performance. Basically, if you are doing things more things at the same time, then you do them faster. I'm not magic like Noel. I cannot promise that it's faster every time. It's mostly on arithmetic intensive applications where you have arrays or matrices with a lot of arithmetic or bit operations. But still, I mean, there are a lot of things that can fit into that area. For example, you can have graphic processing, you can have signal processing, you can have a lot of machine learning operations that depend on operating on arrays and matrices. So yeah, there are many things. And how much faster can we get, right? So if it's 2 times, maybe it's not worth it. So let's look at an example. And for that, I have here what I was just saying before. So we have 2 arrays, 500 elements each. We want to add them together, and I have 3 implementations. The first one is just the straightforward implementation that I showed first, which is just iterate the array and add elements one by one. We can see that if we run this for 5 seconds, we can do 27,000 operations. Then I have 2 implementations that use this sort of vector instructions, and just using different approaches. We're exploring where it makes sense to just implement each operation as a single VM primitive, or if we can build bytecode that is kind of like higher level, and we can then compose them. So the first one is bytecodes. You can see that I run this for 5 seconds again, and this is 2 million times. So compared to 27,000 times, it's pretty better. And then if I run the last one, which is a primitive, which is pretty much like code in something that is very close to assembly, then you get to 8 million, which is, so if I'm terrible in math live, so I know, but it's like several orders of magnitude better, right? So takeaways from this. Number one, well, we're working on these sorts of operations. We have already implemented many operations on arrays, and this is basically the test bed for trying out different approaches, right? We saw that building operations with something that is very close to assembly is super performant. Still, I mean, we work in the VM, it's sometimes low level. We will wish it wasn't always like that. So it would be great if we can have some higher level bytecode that we can compose, and then we don't need to always be working with assembly. And so the open research we're doing now is, okay, can we have the best of both worlds? Can we have bytecodes that are easy to compose, but still are performant enough as the just pretty like handwritten assembly? But also, while we were working on this, we started to notice that there are some operations that could be really speed up kind of easily. For example, we have a primitive for creating objects, and actually using vector operations to speed up object initialization, which just means like going over all the attributes in an object, just saying like this is nil, 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 nil. It's faster if you do it like by several elements at the same time. So we just, for example, have one operation that makes it twice as fast as before to initialize objects. And here's where you come in. If there are use cases that you think will be fine or will be a good match for this sort of operations, or you think that maybe, perhaps, it could help, let us know. Maybe it makes sense. We already heard about the array comparison. We heard about operations using points. We heard of matrices, but if you have any other things, come. That's all. Thanks.